That one, I don't know who that one is, but whether it's next to a church. Trying to wait for my network to stabilize so that I can proceed. Okay, thank God I'm back. Thank God I'm back, and I think you guys can now get me. Okay, okay, welcome back. And, this is where we have reached before I think that exist here, discussing about static equilibrium. So, for static equilibrium, we are simply looking at the non-motion of actions. For example, when you sit on a chair, you're seated. So the force you're subjecting to the chair is considered to be a static force. And the force the chair is subjecting on a floor is also considered. So cannot carry your weight, but if you can be able to carry your weight, it means your weight is being transferred through, if it's a four-legged chair, it's being transferred through the four legs of the chair. And now, if a man of, let's say, 100 kilograms, which is 1 kilonewton, how do we get 1 kilonewton? It is 100 times, remember, 100 is the mass, and the SI unit of mass, kilograms. So if we need to get it in terms of force, force is equal to mass times acceleration. So if we know the mass, and we've been told that we are going to use the acceleration due to gravity as, let's say, 10 meters per second squared, kilograms per meter per second squared is what we call a newton. So if a man has 100 kilograms, okay, it's going to be 100. In other words, we are looking for the force equivalent, or the force this man is subjecting to the chair, is going to be force is equal to mass times acceleration. If we know the mass is 100 kilograms, and acceleration is equal to 10 meters per second squared, therefore, force is going to be equal to 100 times 100 kilograms times 10 meters per second squared. And that gives us 1,000 newtons as the force. So this force is a static force. It is not the same force as, let's say, a force being subjected by a moving vehicle on a bridge. Why? Because the force being subjected by the moving vehicle is not static. It is actually dynamic. Another example of dynamic forces on a structure include earthquakes. Earthquakes do not come out from a single point. It's actually a vibratory. It's kind of a motion. The waves are moving underneath the ground. So therefore, we conclude that earthquakes are examples of dynamic forces. What else could be an example? Static forces, even when we talk about the walls, the weight of the wall onto the beam, or the weight of the column onto the foundation, all those are considered to be static forces. These forces will never leave their position unless it goes by failure. So any fixture or any installation that you have in the house, a fridge that is placed somewhere in a given corner, that is a static force. It only leaves that point to another point if you, the user of the house, chooses to shift it to another place. So these are some of the things we are going to be looking at. They say that the interest is going to be static equilibrium. Static equilibrium is all about knowing that if we are looking at a three-dimensional problem, three-dimensional problem means we have a problem where we are supposed to check for equilibrium in the x-axis, in the y-axis, and in the z-axis. So if I ever ask you to state the conditions to be fulfilled for static equilibrium, they are equal to 0 if x when summed up to be the problem. Same thing to do with forces in the y direction and forces in the z. That is for a three-dimensional problem. A three-dimensional problem will always have x, y, and z. But for this course, most of our problems are going to be two-dimensional problems. Two-dimensional problems, we are mainly going to deal with x and y. And then also always required to check your moments is equal to zero. So the four conditions that satisfy whether a body is in equilibrium, static equilibrium. One, sum of forces in y, sum of forces in x must be equal to zero, sum of forces in the y direction must be equal to zero, sum of forces in the z direction must be equal to zero, and the sum of moments at any given point must be equal to zero. So here in your notes, and by the way, I hope you, whoever will be having access to these notes, please download them and share with the group members. One of the easiest things to do for yourself whenever you're coming for an online lecture is you must have a hard copy of the notes so that you follow what the lecturer is talking about. When I talk of I am on page 5 of 44, on this page, you can actually go there. As I try to review, you also check. And it is always to your advantage if you can pre-read before you come for the lecture, so that at least you have a basic knowledge of what is going to be talked about, but again, it gives you a better chance to know which questions should I ask. Because I went through these things, I did not understand A, I did not understand B, I did not understand C. So these are the two major branches of mechanics. But materials relate us balancing forces, forces in y, forces in x, forces in that. But at some point, either it will be near to where you will now have to study about what we call the strength of materials. Like I've been saying, how do you know that this chair can actually carry a man of 100 kilograms? What are the properties that are that consist of this chair that give it the ability to resist failure due to a load of 100 kilograms? And all that, the ability of the material to resist or to withstand the external forces subjected to it are usually as a result of the internal forces, the binding forces between the material particles, the material atoms. And that is what you study under what we call strength of materials. So if I asked you to, by now, if I asked you to state the two branches of engineering mechanics, the first one is statics, the second one is dynamics. If I told you to discuss or to show whether a given body is in equilibrium, then you must check whether the forces in the x direction are equal to zero. We will do an example, but for now I'm just trying to make sure we are on the same page. And if someone asks you to explain what you understand by the strength of materials, you simply tell them it is the study of properties of materials to assess their ability to withstand external forces. So, definition of basic terms was static equilibrium is one of them. Then forces, what is of big interest in. But mainly, under engineering mechanics, we are going to be playing the math of algebra and trigonometry. Okay, thanks. I love the. It's very unfortunate that my network is on and off, but just have to learn to persevere with some. So even as we want to study the behavior of engineering mechanics is more point. Under engineering field, costly cost strength of materials, we will study about materials response, external forces. So these cost units, you have to tell you're going to add 10 plus 10 and tell me it is 30. No, 10 plus 10 is 20. It is, but is that do not give up. If you can try, please try. His commitment, student has not given me a perfect answer, but there was a will